In this video, we're going to go over how to find a probability distribution and the expected value of a game. This will start you down the road to your first summative assessment. So in this game, it says you're going to draw one card once from a deck of 53 cards, and here are the different outcomes. So the random variable that you're going to be working with is the amount of money won. So again, to find the probability distribution, you are trying to find all of the different possible values of X. So that is all of the different possible amounts of money that can be won. So you could win $100, you could win $10, you could win $20, or you could lose $5, which is -5. So because there are 53 cards in the deck, the probability of winning $100 means you have to draw the joker. So the probability of winning $100 is the probability of getting the joker, which is 1 out of 53. The probability of winning $10 is getting an ace, and there are 4 aces out of the 53 cards. And the probability of winning $10 is getting a face card. So there are 12 face cards out of 53. And the probability of losing $5 is for any other card. So there are a couple of ways you can do this. The first is to figure out how many other cards there are. Alright, so we have all the cards from 2 to 10, which means there are 9 different cards from 2 to 10, and there's 4 suits, so that makes 36 outcomes there. We're not going to have any aces, and we're not going to have any face cards, so that means there are 36 outcomes out of 53. Now, one way you can check your answer to make sure you're correct is that the sum of all of these in the numerator should equal 53, should add up to 53, and then 53 out of 53 should make all of these fractions add up to 1. So 36 plus 12 is 48, plus 4 is 52, plus 1 is 53. So when you add up all of these, you get 53 out of 53, so that means the sum is equal to 1. The other way you could have figured out the other cards is you could have just taken the 53 cards that you had, subtract the 1 joker, subtract the 4 aces, subtract the 12 face cards, and that would have given you 36 cards. So anytime you have something like any other card, you could add up the ones that are left, or you could take what you start with and subtract the ones that you've already used. Now, the expected value, which you learned in the previous video, is the same as the average. This was the formula that was used for average in Unit 3. So it's the sum of each data value multiplied by its frequency divided by the sum of all the frequencies. So in this case, the outcomes here are the data values. So in that formula, you're going to add up each X and you're going to multiply it by its frequency. In this case, that is the frequency. Now, because it's a fraction, it's actually called a relative frequency, but it's still a frequency. And then when you add them all up at the bottom, you're dividing by the total of the frequencies, which is just 1. So you really don't have to write the 1. But if we were going to write this out to figure out the expected value, which means the average amount of money won, so we would start with the first outcome. You can win $100 and you multiply it by its frequency, which is 1 over 53. plus the next outcome, which is 20, and multiply it by its frequency, 4 out of 53. The next outcome is $10 multiplied by its frequency, which is 12 over 53. And the last outcome is -5 multiplied by its frequency, which is 36 over 52. And then divide it by the sum of all the frequencies, which is just equal to 1. So because you're just dividing by 1, you really don't have to write that. So this is the reason why the expected value, which is really the same as the average, is written a little bit differently. It's just written as the sum of each value of x multiplied by its probability. And the only reason it doesn't have the divided by is because the sum of all the frequencies is going to be 1. So you don't have to show dividing by 1. So it's just taking each value of x and multiplying it by its probability and then adding it all together. And this works out to approximately 2.26. And because our random variable is the amount of money won, round it to 2 decimal places, and it is in dollars. Now, as a shortcut, and this would only work if all of the, oops, that should say 53. This would only work if all of the denominators are the same. Let me just fix that up. So a little shortcut that you can do in your calculator, which only works if all the denominators are the same. So you would just take 100 times 1, which I'm sure you can just type in 100, plus 20 times 4, which I'm sure you could just type in 80, plus 10 times 12, which I'm sure you can just type in as 120, minus 5 times 36, and because they all have a denominator of 53, figure out what the numerator is, press equals, and then just divide by 53. And that also gives you approximately $2.26. So you can write it out either way, and you can type it in either way into your calculator, but that involves a little bit less work in your calculator. So when expressing what the expected value means, there's a particular way you want it to be written. So what you're going to say is, on average, the player will lose approximately $2.26 per play. So that's just for playing the game once. They're expected to win approximately $2.26 per play, because the answer is positive, so they are expected to win. So when you write out what it means, the 4 things I'm looking for is you need to say that it's an average. You need to say that this is happening from the player's point of view. You need to say how much they're going to win or lose. So if the expected value is positive, the player will win. If the expected value is negative, the player will lose. And you want to say that this is per play. So that's one of the easiest possible games. But just to summarize what we just talked about, if your expected value is positive, that means your probability of winning is greater than your probability of losing. If your expected value is negative, the probability of winning is less than the probability of losing. And if your expected value is equal to 0, that means your probability of winning is equal to the probability of losing. And this is called a mathematically fair game. Oops. And you'll need to know that terminology because in some of the questions that you get, it will ask you if it is a mathematically fair game, which means you have to calculate the expected value and determine if it's 0. So the probability of winning being greater than the probability of losing is a positive expected value. That's good for the player. The probability of winning being less than the probability of losing with a negative expected value, which means that's good for the house. Now, the house is the person running the game. All right, so we're going to get into a bit of a more complicated game. And in this game, it involves more than one step. So when you have a game that involves more than one step, what you want to do is make a tree diagram. So in the first round, you're going to roll a die. If it's a 1 or a 2, you win $5. If it's a 3, 4, 5, 6, then you're going to draw a card. So the first round is rolling a die. Now, because there's 6 outcomes on the die, it doesn't mean that you have to draw 6 lines. What it means is we really only have 2 outcomes, winning $5 or moving on to drawing the cards. So you're just going to draw 2 branches. And in the first branch, you could roll a 1 or a 2, which means the probability is 2 over 6. And in that case, you win $5. In the second case, if you roll a 3, 4, 5, or 6, you're going to move on. And the probability of doing that is 4 over 6. When you draw the tree diagram, there are 3 things you need to label. You need to label the outcome, you need to label the probability, and when a branch leads to the termination of the game, you need to write down how much money the player walks away with. Now, if they roll a 1 or a 2, they win $5, but as you can see, it costs $10 to play. So what you have to do is subtract $10 from that, which means they actually win negative $5. Now, moving on to the second round. Second round, we're going to draw a card. So how many outcomes are there? Well, we could draw a club face card for $50, a red face card for $10, $5 for a spade, and $0 for anything else. So there are 4 outcomes in the second round. All right, so the first possibility is winning a club face card. And that probability is there are 3 club face cards out of 52. The next outcome is a red face card. So there are 6 red face cards out of 52. The next outcome is a spade, and there are 13 spades out of 52. And the last is anything else. So again, what you can do is you can add up all of the different cards. So what we have is the aces to the tens of the clubs, hearts, and diamonds. So that means there's 10 cards for 3 suits, which is 30 cards left over. Or you can take the 52 cards that you started with, subtract the 3 club face cards, subtract the 6 red face cards, and subtract the 13 spades, and that also gives you 30. So the probability is 30 out of 52. Now these branches all terminate into money. So a club face card is $50, but we're going to subtract the $10 to play, which means the winnings are $40. Red face card is you win 10, but it costs $10 to play. So you actually win 0. For a spade, you win $5, but it costs $10 to play. So you walk out with negative $5. And for other, you win nothing, and it costs $10 to play. So that means you lose $10 overall. So that's how you draw your tree diagram. With each set of branches, you label with the outcome, the probability, and the amount of money you walk away from. When you go to make your probability distribution, it's easiest if you list your outcomes in either ascending or descending order. And then you use your tree diagram to help you figure out the probability for each outcome. So the probability of winning $40 is this branch right here. And I like to either check it off or put a mark under each branch so that I know that I've counted each branch. So to win $40, it means you have to roll a 3, 4, 5, 6, which is 4 over 6. And so you have to remember all of your ands and ors from Unit 1. And you have to draw a club face card. So that works out to 1 over 26 in lowest terms. If you just use your fraction buttons on your calculator, you can put your fraction into lowest terms, but no decimals. That's very important because if you use decimals, when you go to check your answer by adding it up to see if it equals 1, you're not going to get exactly 1. So now, the probability of winning $0 is this branch here. So that means we need to roll a 3, 4, 5, 6, which is 4 over 6, and you need to draw a red face card, which is 6 over 52. And in lowest terms, that works out to 1 over 13. The next possibility is losing $5. So to lose $5, that would be rolling a 1 or a 2, which is 2 over 6. But there's also another case where you can lose $5. So it's this case or the second case, rolling a 3, 4, 5, 6, which is 4 over 6, and drawing a spade, which is 13 over 52. And in lowest terms, that works out to 1/2. And the last possible outcome is losing $10, which means you have to roll a 3, 4, 5, 6 and draw the other card. So there's probability of 4/6 and draw the other card, which is 30/52. And in lowest terms, that works out to 5/13. And again, what you want to do is add these all up to make sure that they equal 1. So get out your calculator, add up 1/26, 1/13, 1/2, 5/13, and you will see that that is equal to 1. So again, our expected value is our first outcome multiplied by its probability plus our second outcome multiplied by its probability and our third outcome multiplied by its probability and our fourth outcome multiplied by its probability. And you divide it by the sum of the probabilities, which is equal to 1, so you don't need to do that. And that is going to work out to approximately -$4.81. So what does the theoretical average mean? On average, this time, the player will lose approximately $4.81 per play. So again, the four things we want to see is it's an average, the fact that it's from the player's point of view, how much will be won or lost, and it's lose in this case because it's negative, and you have to say per play. So maybe what you should do is, if you want to give yourself a little bit of challenge, pause the video, try this one. The tree diagram is a little bit more involved, but pause the video, try it yourself, and then come back to the video and we'll take it up. So pause now, give it a try. If you make a mistake, just erase it, but give it a try and we'll take it up. All right, so welcome back. The first part is rolling a 10-sided die. And doesn't mean you have to make 10 branches because there's really only 3 outcomes. Getting a 0, getting a 1, 2, or 3, or getting a 4 or more. So the first set of branches will be 3 branches. And in this case, you are getting either a 0, a 1, 2, or 3, or 4 or more. You can write greater than or equal to 4. So the probability of rolling a 0 is 1/10. Rolling a 1, 2, or 3 is 3/10. And rolling greater than or equal to 4 is going to be 6 out of 10. Now you have to ask if any of these branches terminate. This branch terminates. So that means you win no dollars, but it cost $10 to play. So your winnings are -10. And it's really important to keep yourself organized like this because when you get to your summative is going to be games that are way more complicated than this with many, many more branches, and keeping yourself organized is what's going to be helpful to you. All right, now, if you roll a 1, 2, or 3, you flip 2 chips. For the two chips, there's different colors on each side. So if you flip them and the two chips are the same color, you lose 10. If they are different colors, you win $100. So there are two outcomes that are going to come off this branch. So in this case, they're either going to be the same or they're going to be different. And if you're not sure what the probability is, you can draw a little separate tree diagram. So when you flip the first chip, one side is red and one side is yellow. So that's flipping the first chip. And the second chip, you can flip a red or a yellow, a red or a yellow. So this outcome is red and red, so those are the same. This outcome is red and a yellow, which are different. This outcome is yellow-red, which is the same. And this outcome is yellow-yellow, which is different. Now, because the probabilities are the same, it's 50-50 everywhere, you can just look at out of the 4 possible outcomes, 2 out of the 4 have the same color, and 2 out of the 4 have a different color. So both of these terminate, and it says if they're the same color, you're going to lose $10, but you also paid $10 to play. So that means you leave with negative $20. If they are different, you're going to win $100, but it costs $10 to play, which means you walk away with $90. And the last part of the game was rolling something greater than or equal to 4, and you draw a card. There are 3 outcomes: a spade, a club, or a red card. So a spade, a club, or a red card. So drawing a spade, that's 13 over 52. Drawing a club, that is 13 over 52. And a red card is 26 over 52. Now some of you might ask, can you just write 1 over 4, 1 over 4, and 1/2? Yes, you can. Same way over here, 2 over 4 and 2 over 4 are both 1/2. So you could have just put 1/2 for each of these. So it doesn't matter if you put your fractions into lowest terms here or just do it at the end. So if it's a spade, you win $10, but it costs $10. So that means 0 at the end. A club is $100, but it costs $10 to play. So the end result is $90. And a red card, you lose $10, and it costs $10 to play. So the end result is negative 20. So for our probability distribution, in order to win $90, there are 2 outcomes. The first outcome is rolling a 1, 2, or 3, which is 3 out of 10, and flipping 2 different colored chips, which is 2 over 4. But you have another case, so that is OR. So it's always OR, which means plus in between 2 different cases. The other way that you could win $90 is to roll a 4 or more, which is probability of 6 over 10, and draw a club from the deck of cards, which is 13 over 52. And that works out to 3 over 10 in lowest terms. So the next outcome is winning nothing. So to win nothing, there's just one outcome, which is rolling a 4 or more, which is a probability of 6 over 10, and drawing a spade, which is 13 over 52, and that works out to 3 over 20 in lowest terms. Our next outcome would be losing $10. So to lose $10, you have one outcome, which is just rolling the 0. A 10-sided die goes from 0 to 9, not 1 to 10. So that's just 1 over 10. And our last outcome is losing 20. So you've got two outcomes here. So to lose 20, you roll a 1, 2, or 3, which has a probability of 3 over 10. And you're going to flip the same colored chips, which is 2 over 4. Or the other option is rolling a 4 or more, which has a probability of 6 over 10, and drawing a red card, which is a probability of 26 over 52. And that works out to 9 over 20. And before you move on, you of course want to check to make sure that it all adds up to 1. So if you add 3 over 10, 3 over 20, 1 over 10, 9 over 20, if you make them all out of, you could use your calculator, but if you make them all out of a fraction of 20, that gives you 6, plus 3 is 9, plus 2 is 11, plus 9 is 20, 20 over 20 is 1. But you could use your calculator if you want. Now, if it all adds up to 1, it does not necessarily mean that you are correct, because you might have made a mistake up here and a mistake down here, and they kind of balanced each other out. But if the sum does not equal 1, for sure you've made a mistake. And to get your expected value, you take your outcome, 90, multiplied by its probability, 3 over 10, plus the next outcome, multiplied by its probability, and the next outcome multiplied by its probability, and the next outcome multiplied by its probability. And when you put that into your calculator, you will get exactly $17. So what does it mean? On average, a player will win $17 per play. And again, the 4 things you want to say: average, player's point of view, how much they'll win or lose. This is a positive 17, so they'll win, and it's per play. So that's how you find the probability distribution and expected value for a game. And just remember, whenever there's more than one round, you want to draw a tree diagram. Each tree diagram should have the outcomes labeled, the probabilities labeled, and the amount of money you walk away from labeled. And when you go to do your probability distribution, what you want to remember is within a case, it's an and, so you're multiplying. So within this case, it's rolling this and flipping those. And between cases, it is or, so you're adding. So if there's anything here you didn't understand, make a note of it and ask your teacher in class the next day. Thank you. Bye-bye.